I'm Robert Smith. I'm here today, kind of three hats on. One, Dark Peak Analytics, another University of Sheffield SHAR, and a third, Humanity. The logo's down there. And the work I'm going to talk about today is in collaboration with Paul Schneider and Wael Mohammed, who are based at University of Sheffield as well, and Dark Peak Analytics. So I'm going to talk today about completely open source, kind of reproducible example project that we've done. It's a bit of a toy project, and I'll explain kind of why we've kind of gone about creating this, what it's potentially useful for, and the problems that it's looking to solve. But it's very much kind of a tutorial style project. Everything's open source on GitHub, and the idea is to kind of pull the industry and bring the industry along with us. So we're not trying to sell anything, not trying to show off anything. It's just a case of making everything very open and transparent. So before I start, I should say I'm part of a scientific committee, which is R for HTA. And so I'm going to massively endorse R generally for our industry. And this work was supported by the Wellcome Trust, as well as Humanity and Dark Peak Analytics. So I'll start with a little bit of a description of what health economic evaluation is, kind of what the health economics industry is doing, just to give you a little bit of context, and then probably go into the thing that's probably more interesting for you guys, which is how is our industry changing, what's the current process, what does the future look like for the health economics industry and health technology assessment industry, and then I'll go through kind of some of the methods here, so including Plumber, used to generate an API, an R script, which calls the API and generates a kind of a living report with our markdown, and then a GitHub Actions workflow which automates this whole process. And then finally, if we've got time, I'll go through a small Shiny app which allows non-technical users to kind of undertake this process for themselves, and was a bit of a proof of concept for us for testing whether or not we could get somebody to build the app who'd never actually seen any of the model code. So a bit of background for health economic evaluation. So you can imagine every year there's thousands of new pharmaceutical products, health interventions that are created, invented, and all of those want to enter the market. And so there's a whole process now in the health economics industry which aims to determine the value of these different interventions in a clear and transparent way to inform commissioning decisions by the NHS, often through NICE. And so the current process for a lot of these health economic models, so if I simplify it down and just discuss a simple pharmaceutical intervention, there might be some survival modeling done, for example in R, and extrapolations generated from some clinical trial data. Then what's kind of discouragingly currently done is a lot of that the results from that analysis will be plugged into a health economic model, which is constructed in Excel generally at the moment. And then a load of plots will be created, and the model might be run in VBA, so it can be run thousands of times to take into account uncertainty in different parameters. The outputs from that typically be some plots will be created using Excel, and then they'll be thrown into a Word report, and then that Word report and a presentation will be submitted at one point in time generally, and that's kind of the end of it, and then some new data will emerge, and this whole process will kind of repeat again. Manually, a lot of human input, and very inefficient kind of copying and pasting of data from the results sections into Excel, and then plots into Word, and then into PowerPoint presentations, and the whole thing goes. So what we're trying to kind of push the industry towards as a group, our HTA group, is this kind of process where we have the original modeling, survival modeling, being done in R, pretty much as it is, and then the results from that being fed in automatically into a health economic model that's built in R, and the HeSim is one example of that, but you could write any of these models yourself in base R if you wanted. A load of plots would then be generated using ggplot, and they'd be automatically inserted into a report which is written in R Markdown. And then this whole thing, so the model itself can be queried, and different kind of underlying assumptions can be made using a Shiny app, allowing users to play around with assumptions that are made in the model themselves in real time. So you imagine a nice committee meeting. We could then have clinicians saying, okay, so what about if our assumptions on this were wrong? Can we rerun that model and incorporate uncertainty? And previously, they'd have to kind of take that report and say, oh, I disagree with that assumption. Can you redo all this analysis? But obviously, with Shiny, they can do that in real time. And what might take hours to run in Excel can take seconds to run in R. So that's kind of the future process. So Paul and I, back in 2020, published a paper called Making Health Economics Shiny. And it got a lot of interest in the industry. And the idea was, it was a tutorial paper, basically taking a health economic model that was constructed as a tutorial model in the Netherlands, and wrapping that model up into a single function and showing how it's fairly straightforward to kind of insert that into a Shiny app to allow users to play around with parameters and better understand that. And so that got a lot of interest. And so that was kind of our first kind of foray into doing some teaching on this kind of thing. And that's been great, and we're still doing a lot of that. But then we got interested in, or the issue with that is still, there's a lot of data sharing between, say, the pharmaceutical company and some consultant who's going to build this app. And so typically what might happen is the company might still want to send their data to the consultant. And the problem with this is that every time that data gets updated, they need to then send the data. So typically, in our industry, there's a lot of cases where the company is uploading data to SharePoint or sending it via email to consultants to run analysis on, which is just quite an inefficient way of doing this. And there's a lot of paperwork involved in sharing, especially individual level data. So this kind of latest project that I'm going to discuss today, I guess called Making Health Economics Happy. And we're going to kind of briefly go through a way in which we can keep that data contained at the company while still allowing the consultant to kind of write the code for the model and kind of continually update that process. And there's an open source paper, a method article published on Welcome Open Research, so you can look at that now. It's been peer reviewed by one reviewer, second reviewer still to review, but it's very much a transparent, open process. And if you're interested in an expert in this area, you can comment as well as those reviewers. It's quite a nice situation. The code, paper, everything's up there. So I could talk about the whole process today, but I'm not going to have enough time. So the GitHub repository contains an R script, which contains the entire health economic model. So it's one script with a load of functions, which run a Markov model in R with C++, helping it speed things up. There's also a Plumber script, which is used to generate an API, and that sits on the client, the company side. So the GitHub repository is kind of organized as the company and the consultant separately. There's then an R Markdown file, which was used to generate the model report, and an R script, which is used to use the first three scripts there to generate a report without accessing the original data. So the data is contained on the company side, and this R script is going to query the API, and it's going to send the model to the data, run the model on that data, and then send back some results. And then there's a GitHub Actions workflow, which automates 4 on the first of every month. And then there's also an R Shiny app, which allows non-technical users to query this API. And so the idea is this is kind of containing a whole project workflow to try and kind of teach people in the most simple way. So it's all in kind of generally base R, using some of these smallest number of other packages. And it doesn't involve things like Docker. It's trying to kind of pull the industry, people that are new to R, towards this way. And if I go to this one, so I'm going to focus today on the Plumber script used to generate the API, mainly because a lot of you won't care about the health economic model, what that looks like, and R Markdown is generally done to death. And then I'm going to focus on the R script, which uses the first 3 sections to update a report, so see how that Plumber API is actually queried, and then, if I get time, go through the GitHub Actions workflow. So going back to how this whole process is kind of set up, so you can imagine you've got a company, maybe a pharmaceutical company, and that company has a load of sensitive data that they don't want to share. And so they build a very simple API on their side that allows the consultant to send some code, some model code, to that data, and then run that sensitive data, run the model on the sensitive data and return just some results. And that whole process is going to be automated using GitHub Actions. And then what we're going to end up with at the end of that process is a single report which gets updated on the first of every month with whatever data exists in that sensitive data section. And so the idea is that we've got trial data up to 24 months or 18 months, and then that trial data gets updated to 24 months and 36 months, 2 years, 3 years, on and on. We don't have to keep sending data from the company to the consultant. That can just continually update. So you won't be able to see in detail the code there. I'll go into a little bit more detail if needed later. But this is essentially the Plumber script, which is used to generate the API. And this is hosted on our Studio Connect at the moment on Bresmed servers. So Bresmed's part of Lumanity. And essentially what this script is going to do is create the API needed that we're then going to query and send the model to. So the script starts by loading some necessary packages. So we're going to need Plumber, for example. And then Plumber works, those of you that are in the course yesterday, it's probably taught much better than I can possibly describe it. But it's set up essentially how a function would be written with Roxygen comments. So it's Roxygen style documentation for the function. But just really briefly here, what that function is going to take is it's going to take a reference to a GitHub repository and a location for the model. And that could be controlled by the person that controls the data as well, so that they can accept and reject pull requests to change that underlying data so they know what's going to be run, so limiting security concerns. And then essentially all we're going to do here is source the model functions from GitHub. We're going to overwrite any default data with our non-sensitive inputs. And then we're going to run the model, and we're going to run some very simple checks to make sure that what's being returned is not the sensitive data that we were concerned about, and then we're going to return those results. So for more details about Plumber, please look at that. And so we can see this code a little bit clearer here. So we've got a path to our data, and in the repo, I've just stored it in a CSV file. In reality, you'd probably have some proper database set up there. And what is stored there is just some really simple parameter distributions. And we're just going to go through the process of how there is some sensitive data that's stored there that we're worried about, and then there's some other data that we want to be able to send to the model to run, because that's the non-sensitive data. And so all this code is doing is it's going to source those model functions, it's going to read in the data that it needs internally, and then it's going to take the data that's passed externally into the model, that's the non-sensitive data, and it's going to combine those two things. It's going to run the model, and then it's going to check that there's nothing that shouldn't be returned, and then it's going to return the results. And so then, from the side of the consultant, they can then load the necessary packages, and they can use the HTTR package to call the API. And so all they're going to do is pass the link to the code that they've created, and the data that's not sensitive to the other data. It's then going to be combined, and then you can see at the bottom here we're going to write the results to a CSV, and then we're going to render our Markdown document, and our Markdown file is on the GitHub repo there. And then this whole process can be automated using GitHub Actions. So again, you can use any service. I've just used GitHub Actions because for a lot of people who are new to this, that's probably the simplest. It's a free solution. And so here we schedule a job using cron based on whenever there's a push to the main branch or at a scheduled time. So the first minute, the first hour of the first month, first day of the month. And then we set up a load of code, installing R and some dependencies, and then we run that script, which I've just briefly talked through, which queries the API and creates a report with our markdown. And then it creates a pull request to the repository with the new markdown report included. So every first day of the month, the company would then get a pull request saying, here's your new report. I can very quickly... And so part of the reason for wanting to do this is that rather than having people who are building these shiny apps to showcase these models and be able to run these models in real time, having to have the data, we can have somebody external who doesn't need to sign a load of data security forms and confidentiality agreements and all that kind of thing. They can be building these apps because they don't actually have any of that sensitive data. And so as a trial run, we got Zaid to build this for us. And so we built this app, and then we have the API call. And so when we go to the model, we should have something come up, and you just insert your API key and connect. And then now we can run our model. And so that's sending the request to the company server, and it's running that model in the background. So it's run, I think, 10,000 iterations of the probabilistic model. And then we can see our results. And then we can change any of these parameters and rerun the model ourselves, because these are kind of the non-secure parameters. And so this is our kind of incremental qualities of the intervention and incremental costs of that intervention. So hopefully that kind of gives some context for why that's useful. If there are any questions, feel free to reach out. And as I said, this is a teaching tool, so we're really, really keen that people kind of contribute and feel free to comment on the repo. There's a discussion going on the repo. As I've said, a big concern here is security, so that's a big benefit, and having data owners retain control of their data. And transparency is the other big one for me, is being able to separate the model code from the data means that we can have all of our code up on GitHub, and so any interested party, since a lot of these products are essentially funded by the taxpayer, anybody really should be able to go and see what the justification for their funding is. And yeah, I won't go into a huge amount of detail, but the limitations and disadvantages are essentially the technical skill set. You have to have somebody on the inside of the company who is able to host this API for you. And just generally, the whole industry has got a long way to go in terms of people working with R. So I presented this at the R HTA conference, and like even with the group of people who are really interested in art, a lot of it kind of went over people's heads. So a lot of what we're doing is actually just teaching the basics. So this is something for the future and hopefully useful. And that's just, yeah, a little description on who can access what. So, cool. And further resources. I think I'm roughly on time, but.